So in this video, I wanted to illustrate some of the bugs that can happen in this app. So let's choose a big matrix and let's choose rank 5. Let's get some big numbers. Okay, so we have this 23. So the errors that I'm aware of, basically the bugs, basically has to do with the fact that if you start dividing, you can get some small numerical errors that are enough to show. Particularly if it's 0, it's supposed to be exactly 0. It'll be very close to 0, and so it'll be an error. So let's just divide by 23. So now we have these negative 23s floating around. Let's see if we can use row operations and see if that gives us an error. Pull this up. Now we have this. Just continue as far as we can using row operations and see what happens. So we have this, 1. Typically the errors that we're going to get. Okay, so we see the stars here. These should be 0. Why should it be 0? We have 4 pivots, and it's supposed to be rank 4. So we know that this should all be zeros here because they have 4 pivots, which is just rank 4. So these should all be zeros. If I take these, they're actually very small and non-zero. If I take them, I can turn them into 1. They should be zeros though. So I should get a divide by 0 error, but I don't. So that's a mistake. That's just a bug. So another thing you can get is that's basically the error I'm aware of. It's just 23. Let's see if we can do it in a way that doesn't involve that error by not dividing by 23. Let's do the 2. And let's actually not do any division if we don't have to. So this 2 cancel the 4 really nicely. And we'll just cancel out like that. And then we'll leave the division for last, basically. Oops, I don't want to click that. So 9/2, we'll cancel this out nicely. By multiplying, it cancels. This one's kind of hard, but you still have to do some division no matter what. This right here, cancel this out. 5. It's kind of hard. Let's say 5 is our pivot. Use 5 to cancel this. So this, we use to cancel this out. And we still have these numerical errors. So we couldn't avoid it really, as far as I understand. So let's just cancel this out, cancel this out, this out. So this should be our row reduced echelon form, except these aren't 1. So let's turn these into 1s now. And these should be zeros down here. And sometimes another error that can happen is even if it says zeros here. So let's actually turn these into this. So this right here should be row reduced, which it says it is. Let's see if we can cancel these out. It's going to be in row reduced echelon form. And what we see, this should cancel out that. So yeah, it says it's correct. This is just a completely incorrect answer because we took 0, we divided by 0, and we got 1. So this is just illustrating some of the bugs. Sometimes what it can do is it can look like it's in row reduced echelon form, but the light won't show. And the reason is the number here, even though it looks like a 1, it's actually not a 1 because there's a small, it's like 1 plus a small error. And so it's not registering as 1 when it's checking to see if it's in row reduced echelon form. However, based on the way it's being displayed, it's showing a 1. And the idea behind these errors is that there is a matrix in the background as a data structure, and the data structure is a matrix of doubles. And MATLAB AppDesigner doesn't allow you to use symbolic arithmetic, so you basically are stuck with using doubles. And the way it's implemented now is just you see a 5 by 6 matrix of doubles. And so if you do these arithmetic operations, you end up getting a small error that accrues, especially if you do division and multiplication with the bigger numbers. With these bigger matrices, you tend to have problems, but if you do a smaller matrix, it doesn't tend to have so many problems. And if you do this rank requirement, it does bring in some problems because how I make the matrix have this rank requirement, it involves taking some rows, number of independent rows, and generating more rows from it. I'm aware of a way to try to fix the error involving just keeping, like here, instead of having 106 over 99, which actually isn't the number that's being stored, it's actually a double, so it's a decimal. And what I could do is store the numerator and denominator separately, and then do all the arithmetic myself through MATLAB. And it's just fraction arithmetic. So that way, the only error you would really get would be small little errors, and I can do is just round each step along the way, and so you can basically throw away any small errors that you see. However, that's just not the way it's implemented right now, and so there are these bugs. So I hope that video was interesting. Have a nice day.